what is algorithmic AI teaming, the AI attack surface. We're going to be looking at case studies of real-world cyber attacks, threat models. We're going to be looking at using MITRE ATT&CK and MITRE Atlas to map the attack vectors. We can look at identifying attack pathways in an enterprise system, and I'm going to do a hands-on demonstration of a simple AI evasion attack. So that's the schedule for the first session. Actually, the course tomorrow has 4 different sessions, and usually I do the preparation on YouTube for some of them, not for all of them, because that's 4 hours of talking, and I upload them to get feedback. So if you're interested in the full course, you can watch it there, or you can subscribe to the channel. Eventually, most of the same information would feed back to the YouTube channel, because I work in that specific area of red teaming, cybersecurity, of algorithms, generative AI algorithms, and various different algorithms. So this will eventually show up on the YouTube channel, just not tomorrow. If you're not in a hurry to watch those videos, you would be able to watch them eventually. So session 1, just to start with what I have prepared, usually I have like a 1 web page of a standard or a specific regulation or a specific methodology or a framework. So I'm going to be looking at that first. This is going to be from Robust Intelligence, which is part of Cisco Systems Now. Then usually I also have like whiteboards. I do drawing to explain some of the concepts, because some of the concepts can be quite technical. So it's easier to do the drawing than just use the PowerPoint. And I also have PowerPoint slides that I'm planning to use for the session. It's a combination of 3 things. So you start with lightweight, with discussing few standards, then you move on to more practical applications. So let me just open that one, just the PowerPoint slides, and this is me. So that's who I am. The course that I'm going to be doing, as I said, is going to be part of with Pearson & O'Reilly, but I work for the University of Oxford. Let me show you my profile in case you're interested. That's my whole biography over there. Not very regularly updated. I think I asked them to update it once a year. That's more than enough, but it contains loads of information of the type of work that I do. They have also a second web page where they talk more about news and events that are happening, things that I publish. But the best way to read all my publications, it's Google Scholar, and if you click here by year, the most recent ones will show up. So those are the ones that I published in the last few months. You can read them for free. They're all open access. University of Oxford has paid, so you just click there and the PDF will open. University of Oxford has paid around £3,000 for each one to be made available open access. And it is as simple as clicking and reading, but most people don't like to click and read. Most people prefer to have a video. We get the whole education on YouTube now. That's how the world operates. So first, what was the first task of the schedule? Overview of algorithmic red teaming. Well, what is red teaming? Red teaming is when you trace the attack lifecycle, you recreate scenarios, and then actually I think maybe the PowerPoint would explain this better, because I do have slides for this. Let me get rid of my face. You don't really need to see me. And in this one needs to go to maximum. So what is red teaming? There's various different definitions, but red teaming usually originates from military strategy. So usually it's adapted to cybersecurity, but originates from the military, when the armies were simulating adversaries to test the defenses of a system. And this is usually done through penetration testing in computer systems. For example, phishing simulations, social engineering, but also physical intrusion testing. That's also part of red teaming. In cybersecurity, red teams test how the organization detects, responds, and recovers from attacks. And the key idea here is, don't wait for a real attack, simulate one today, and then you know what the attackers would be able to do to your network. It's not always that easy, because quite often companies, they don't want you to demonstrate that you can break into their defenses. So they say, okay, so this is our network, but you can only test this part, and the rest of the part, it's off reach for you. Don't even think about touching that one. And that makes the penetration testing exercises less valuable. And here where red teaming comes into play, because you don't actually need to go and break the system. There's different ways how to do it. And then there's also a change from traditional to algorithmic red teaming. The slide that I showed you here, red teaming attack lifecycle, that refers to normal red teaming of IT infrastructure. Here we're looking at AI specific red teaming. And what's the difference? Well, it's just an extension of red teaming, but it's applicable to machine learning and AI systems, so it's specific. The differences are that algorithms are used as an attack surface and data as an attack vector. In algorithmic red teaming, we adapt this concept of AI systems that they're basically algorithms and data. And instead of probing firewalls or servers, we now probe the training data, the machine learning models, and the logic of the automated decision-making system. And this shifts from ports and protocols to vectors and embeddings and neural network weights. The attack surface becomes more algorithmic as opposed to IT. And then we're trying to determine how the model processes the input, what assumption it makes, and where these assumptions can be subverted. This is usually best described with a diagram, so I do have some diagrams that we're going to look over here into how that operates, but let's start from the theoretical part, and then we'll move to that part, because we don't want to get too far ahead without even knowing what is it. Hold on, back to this slide. There are multiple definitions, so I'm going to be telling you, let's say, let me think of one definition, which is, why is that not, okay. One definition would be, for example, adversarial input. So those are crafted to cause incorrect and dangerous model behavior. Another one would be exploit discovery, identifying vulnerabilities that emerge from the model generalization. Third would be secure by design, embedding the expectations of attack into the design and the development of AI. So that would be more how I would frame it. Adversarial inputs, exploits discovery, secure by design. But here I do have somewhere actual definition, which I will find it and I will read it, just to read out some definitions of how other people have defined it. But it's the same thing, just not always reads the same. So what is the motivation? Why do we need algorithmic red teaming? We need it because the traditional idea of AI performance measured by accuracy or F1 score, that isn't enough. AI systems now power autonomous vehicles, medical diagnostics, loan approvals, and national security systems. Those are all integrated. And if these systems are vulnerable, then lives are at risk, not just the data. And here the key motivation for this kind of algorithmic red teaming is that you are testing the robustness. You're testing the model performance under adversarial or out of distribution conditions. So that's what we mean by robustness. Second thing, the motivation that you for testing is fairness. So you're looking at the red team to uncover discrimination of bias. For example, facial recognition systems that is misidentifying minorities. That would be one thing that we would test in terms of fairness. Third would be compliance. So there are upcoming laws like the European Union AI Act mandate, and those require this strong testing and stress testing and logging of high-risk AI deployments. Those are the requirements of the regulation. And one more would be safety in deployment. So if you're looking at critical or autonomous systems like drones, cars, robotic surgery, then safety becomes quite important. Here I have an example. The NSA runs red teaming operations against US infrastructure. So Google, for example, has a Project Zero. That project discovers 0 days and reports them before adversaries do. So that's what they're doing over there. Let's see if we can move to the next slide. Okay, so this is what we covered, the extension of red teaming to machine learning systems, the differences, the attack surface, the data as an attack vector. We're looking at definitions. Here are the definitions that I was mentioning. So the formal definition of algorithmic red teaming, not mine one. So remember, my definition of algorithmic red teaming was testing for adversarial inputs, exploit discovery, and security by design. But actual formal definition one would be, I'm reading it here, simulating adversarial use cases and edge conditions to test and stress test AI systems under realistic scenarios. So second definition would be algorithmic red teaming is the systematic approach of offensive testing techniques such as adversarial attacks, model probing, and data poisoning simulations to identify weakness in AI models before malicious actors do. And the key terms here are adversarial inputs, attack surface, AI assurance, and secure by design. So that's why my definition, to me, it's less it's easy to remember, and I know what it needs to do. We need to test for adversarial inputs, we need to discover exploits, and we need to ensure that the system is secure by design. Those are the three things that we need to do in these red teaming exercises. But regardless of what definition makes more sense to you, use that one. It's important just to know what are the conditions of red teaming. So here we already spoke about testing for robustness, fairness, and privacy. The compliance with I didn't mention the actual framework. So we have the AI Acts with the European Union. We have NIST AI Risk Management Framework. In this following few videos, so I'm probably going to cut this one on multiple videos because the session I'm doing tomorrow is 4 hours, but nobody on YouTube wants to listen to 4-hour video. I'm going to do it in small chunks, and this helps me prepare my material for the training tomorrow. If you do have subscription with O'Reilly, you can watch it over there in more polished way. This is where I'm actually testing my arrows and my PowerPoints. So what is another factor? Well, risk mitigation in safety crucial domains that we mentioned, national critical infrastructure like healthcare, cars, autonomous cars, finance. And where does the algorithmic red teaming fit in terms of the life cycle? Well, here we have the data sourcing, model design, testing, and deployment. So first, we need to agree that it fits everywhere in the whole process. Most of the software developers, they would say the testing happens over here after deployment. Problem with the AI algorithms is that once it's being built and deployed, it's very difficult to go back and change the actual training. That's basically going to be easier to build a new model, or it's going to be very time demanding. So it's not at that stage. The algorithmic red teaming happens in the data sourcing, in the model design, in the testing, and in the deployment. So it's throughout the whole life cycle. Why during the data collection? Because, let me wipe those out. Because during the data sourcing and the data collection, poisoned or mislabeled samples can enter your training data. And then that's it, you're infected. Then during the training, for example, model parameters can be manipulated or made to overfit. During validation, then there are unseen edge cases where your validation can set misses. And during deployment, which is this stage here, users can input adversarial prompts or images, and that would change the whole structure. And that means that a strong algorithmic red teaming strategy covers the whole life cycle. It's very important to remember. I supervise multiple software engineers. They would prefer that you don't have any security concerns until the very end when they deploy. That would leave them on their hands untied. They can develop as much as they want and make the system work before you actually test it for security. And who am I to argue? You see, that's how they designed ChatGPT. There was no security people in the room, and ChatGPT is working. It's one of the biggest innovations in our generation. So who am I to argue that maybe that is a correct time to test? What I'm saying is that you cannot correctly test it. So at that stage, if let's say you build this whole pipeline and you have a model and you test it over here, then you might realize that you need to go back to the beginning. And if you're happy with that, then this is the correct approach for you. That's very expensive, very costly. Most of the people would prefer to get it right the first time. But let's look at the next slide. Who performs the algorithmic red teaming? You have internal red teams, external consultants, white hat researchers. So who does it? Well, if none of those people do it, I'll tell you who is going to do the red teaming is going to be the hackers. So it's not just for them. It's how do you build a multidisciplinary team that can actually do it for you before the hackers come and do the testing for you. Well, what you need here is machine learning engineers, first of all. They can craft test cases and adversarial inputs. You need security researchers. They can analyze threat vectors and stimulate attack scenarios. Policy and ethics experts, they need to be here in this stage because they can probe for unintended harms and violations. And then you also need the internal red team because they can develop playbooks to respond to algorithmic compromise and for example, in large companies, especially, they have specialized red teams for AI. And Microsoft has that, Meta has that, Google has that in their DeepMind. These companies have dedicated AI red teams testing the limits of their models. So that's how they do it. And finally, before we end this video, I'm just gonna cut it, end it, and then I'll record another one because people won't watch it. If it's one very long video, 4 hours, first of all, I shouldn't be doing it because I'm doing this for Pearsons and O'Reilly. This is just my testing. That's the actual course that I'm gonna be doing. This is tomorrow, and most of these videos will come out after tomorrow. So today is 1st of June. That's gonna be 2nd of June. Quick examples of algorithmic red teaming. Here are some real world examples that we can think. Computer vision. Here is where an attacker would apply stickers to stop signs so that a self-driving car would see it as a speed limit sign, for example. That's one of the most commonly used examples. Second would be natural language processing and large language models prompt injection attacks on ChatGPT or Bing Chat. Those could force the system to ignore safety filters and generate harmful content. Third one would be model extractions. So you can use API queries to reconstruct an API model. Weights. So if you can reconstruct the API model weights or proprietary logic, then you have the model, at least the important part of the model. Training data attacks, that could be another example. Poison data examples could be inserted into the model training, and that could lead to failures triggered under specific conditions. So it's basically a time bomb. And each one of these, it's not just theoretical discussion that we're having. They have been demonstrated in the wild and in the lab in red teaming exercises. So as soon as we detect them, we inform the companies. Once they patch them, then we release the videos afterwards. We're not allowed to release the videos until the company had time to patch their the systems. So next one would be, we'll discuss what is an attack surface. And as I said, if you're interested in this kind of, just subscribe to the channel and you're going to get the other videos as they show up. I didn't even get to the stage to discuss the web page. I started with the slides. So I'm going to discuss this one in the next video. This is using AI to jailbreak large language models. So here we have an overview and just how that is happening, and how they're basically two adversarial inputs models that they're trying to find the most effective way to jailbreak. But I will do that in the next, hold on, where is it? Here. Oh, I'm back. So I'll do that in the next video. I think it's good to end these videos after like few minutes. I don't even know how long it takes. That's why I'm recording it. I want to time it, because my sessions need to be short and punchy, and if I start drifting away and talking about cybersecurity for hours and hours and hours, they're gonna fall asleep. So I have to time my sessions short and then add demos and drawings in the same time. But I'm gonna end it here, and hopefully I'm gonna create a playlist so you get the messages when the next continuation would happen. And if it's a playlist, then they would automatically, if you turn